All right, let's talk about circuit analysis. So in physics, when we're studying circuits, we're often asked to analyze them and find unknown values for maybe current, maybe potential difference, maybe resistance. So here's an example of a circuit. Battery, resistor, 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 resistor. You might be asked to find the potential difference that's being lost here. You might be asked to find the current in this wire. You might be asked to find the current that goes in this wire. You might be asked to find the current that goes this way, the current in this wire. You might be asked to find the current that goes this way, current that goes this way, current that goes this way, and current that goes this way. Those are all just current values. You might be asked, oh, I already said potential difference here. You might be asked to solve for the potential drop here, and here, and here, and here, and here. And in this question, you're given a bunch of R's, but you, if not given R's, you might have to solve for R's. There's a little chart that sometimes these questions have, and you can fill it in. So for this 3 ohm resistor right here, what is the potential difference? You do some calculations, you'd solve it, you put in the potential difference here, and then what is the current that's flowing through it? You'd put this here. I won't be asking you to solve for power in any of my questions. So you might ask yourself, how am I supposed to do that? So you actually already have the tools at your disposal. So what tools do we know that would help us to find these values? The first thing we know is Ohm's law. And as a little review, I'll write it here, V equals IR. We know that our resistors in series, if I wanted to combine them, I just add them. Yes? I know that resistors in parallel, I add up their inverses. Yes? And there are 2 other things that we know, 2 of Kirchhoff's laws. I know the shopping rule from Kirchhoff. And I'll just scroll down just a tiny bit here. If Mom gives me $12 and I'm going to go into all 3 of these stores, I'm going to spend all 12 of these dollars before I get back to her again. And then there's the car rule. Yes? If so many cars head down this wire, it's the same number of cars all the way along, because there's been no turns, there's no other roads for them to travel, there's only one path. So we have the car rule. So let's try these rules, use these rules to solve this question right now. So I'm given V, the overall V, and I'm given the 3 R's. I can't really use, I'll write it here, I can't really use this guy, because to use this guy I would need to know R1 here, and I'd need to either to know R1, I'd either need to know I1 to find this, or I'd need V1 to find this. And I don't have any other I's, specific I's or V's. I've got totals. So why don't we do something that we've already learned? Why don't we add these 3 together to give one big super resistor? So they're in series with each other, yes? And when they're in series with each other, I just straight up add them together. 3,000, 4,000, 5,000. This is going to be 12,000 ohms. So it looks like I've got our tote, yes? And I've got the total V is 12 volts. If I have the total V and the total R, I can find the current that leaves the battery. So let's put I0 equals V0 over R tote. All I'm I'm doing is using this guy, just rearranged. I is V over R, which is 12 over 12,000, which is 0.001 amps. So that is the current that leaves this battery. Yes? And it's asking me to find a bunch of things here. Did I find our T total? Oh yeah, it's 12,000. And what I suggest to you is you cross them off. Have I found the total I that leaves the battery? Oh yes, I have. The next thing that I might solve for is using the car rule. There's only one path here. The current here has got to be equal to the current here, and 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 here, because there's only one path. There's no splits. There's no other roads to take. So the next thing I might write here is I0 is going to be equal to the current that goes through R1, which would be equal to the current that goes through R2, which would be equal to the current that goes through R3. And all of those would be the same value, 0.001 amps. Now I'm going to take my pen out. Now they didn't actually ask us to do that, so what I'm going to do is I'm going to go I1, I2, I3, and I'm going to cross those guys out. And I'm never going to be solving for power in these. Now I have to find the potential difference drop here, potential difference drop here, and the potential difference drop here. Lucky for me, I've got R1, and I've got I1, I've got R2, and I've got I2, I've got R3, and I've got I3. I can just use this guy right here. V1 is I1 R1, which is 0.001 times 3,000, which is 3 volts. And similarly, I can do the same calculation. Three times. Make sure you never use I1 and some other random number. The subscripts all have to match up in the formula. Now, oops, I'll just put a decimal point. As a little check, how much money did Mom give me? 12 volts, $12. How much am I spending here? 3. How much am I spending here? 4. How much am I spending here? 5. Did I spend it all? 7, 12. I spent it all. That's wonderful. And what I'm going to do is I'm going to stop there and make a couple other videos, each one with their own sample question.